Oh, hi guys, so welcome back again sa akong video, no? And for this day or for this video, our topic is about pressure sensor. So I'm gonna demonstrate to you on how to check the pressure sensor, if the sensor is still good or bad. And our type of sensor is this one. So this is a 4 to 20 milliamp loop powered pressure transmitter. Okay, this is from our one of our equipment onboard, or machinery onboard. And having a problem, so that's why I need to make some video on this type of sensor, just to share with you, especially who wants to learn for instrumentation. So this is AMDC checking, but interesting. Okay, so let's start. Let's go. Okay, so in order to check all the sensors, we should have this multimeter, which can read the milliamps or milliamperes, DC milliamperes. Then this one, pressure calibrator, tools, screwdrivers, and connectors, plug for the sensors, and of course a power supply. Okay, so we need this power supply also. So we need a power supply. Okay, so I'm gonna show you how to connect the sensor, or how to make a circuit in order to test the system or these sensors, no? So okay, we have power supply source, like example this one, voltage plus minus, so DC, volts DC, and then going to example the sensor, which is the pressure transmitter. Okay, so we have to connect to multimeter. So if this is our multimeter, milliamps. Okay, so there's two probe. Okay, red and black. Okay, so the red one, for example, this is the red one. You must connect to this one from the this is positive plus, and this is the negative. So in the plug or the terminal or the connector, this is number one and number two. Okay, so this one. So we have here, we need only two connection for this 4 to 20 milliamp loop powered pressure transmitter. So one is the positive and two is the negative. So this is the positive one and this is the two from pressure transmitter, and going to connect to the red probe. Okay, red probe from the multimeter. Okay, and the black one is the black one, connect to back to the negative source. Okay, so simple is that. This is the simple loop circuit, series circuit. So this is the load, and this is the tester or multimeter tester that can read, or milliammeter, can read DC milliamps. Okay, so let's follow that one. So let's have the source. Okay, let's have the source. So this is the power source, and we have to check if we have power supply. So as per in our this pressure transmitter, we have a source about range 8 to 30 volts. So I have already set our power supply to same as our system. Okay, so let's try check the power source that we have. So brown is positive, blue is negative. Okay, 24.6. Okay, so power supply is good. So next, we have connectors. So this is connected to sensor. So I have already set the connection, this one. So this 1 and 2, this is what we need in this type of sensor. 1, 2, 1 is positive, 2 is negative. Okay, so let's follow this circuit. So source, so we have source, and ground is the positive. So we have to connect to PT, so which is this, the PT, pressure transmitter, and connect to positive source. So this is the positive source, and then the negative white is connected to going to this multimeter. Okay, so we'll use the, so as you can see, you have to also know how to use your multimeter because they have plenty functions. So we have here milliamps, but I already tried out this milliamps, it's not working here. So what we can do is I will use this DC amps. So DC dampers, but the range is still with up to milliamps. Okay, so we'll use change the connection because we will. This one is going to go blue. So after this positive red, this is the red probe, and this is the black probe. So from red probe going to red. Okay, so PT negative, so we'll connect the PT here. So, so now let's go to black. So the black of course going to negative side, so it should be here. So now our circuit is completed. So now remaining is to connect all of this to sensors. Okay, and that's the time we will know that the sensor is okay or not. So using this pressure calibrator. Okay, let's try this sensor. Okay. So assuming that the sensor no apply pressure, so which means zero pressure in this sensor. So we should get in a simple 4 to 20 milliamp guys. So just information. No? So 4 milliamps. Like for example, reference is range of the pressure sensor is 0 to 10 bars. Okay, so 4 milliamps should be at 0 bar, 0 pressure, 0 bar. For output signal 20 milliamps should be 10 bars. So this is what we need to check if the pressure sensor will get this output signal. Okay, so that's the time you can identify if the sensor is good or bad. Okay, so already connected supply, so we will check. Okay, so DC amps. So now we can see we have 0.00 that's about 43, so it's moving around 43. So we need milliamps, so this is amps or ampere. So in milliamps it's thousands, move to decimal to thousands, so 3 decimal is thousands. So from 0.0 move to 3, so 1, 2, 3. So now the current output value is like 3 to 4 milliamps. So which is need adjustment because 3 milliamps is not acceptable, especially to the PLCs. So he will get error or like malfunction that he cannot accept this output signal 3 milliamps. So which means this sensor already some problem, but we will see to the when pressurize the system, or the sensor will become pressurized, he will get 20 milliamps at maximum pressure. Okay, okay, 0 bars, 3 amperes reading. So let's try to pressurize the sensor. So it's, you see, as you can see at 4 bars 6 milliamps, so it's already out of range. It should be around 5 bars, should be more than 10 milliamps already. Oh, 9. So at already maximum value, but the current output still at 14 milliamps. So which means incorrect values giving output signal this sensor. So this is not acceptable. This is already give malfunction to the system. Okay. Let's proceed to another sensor. So there are some sensor guys is you can still check or calibrate by adjustment, but here I cannot see any adjustment on the sensor, so it's look like need to only the supplier or makers can do this calibration. Okay, So this is the X already. Okay. Next, the sensor again. So same type of. So still has 0.003 milliamps. I know 3 milliamps. Okay, so looks like same as usual. So, okay, let's try to pressurize it. Can still use the sensor for just emergency case. Oh, maybe it's still good or can still be used. Oh. So now as you can see guys, I already have 5 bars and already 13 milliamps. So this sensor is can use. There's only a differential, but I don't know how much. But I don't know also this calibrator how much is the error of this pressure. So we will see how much the. Okay. So we got 20 milliamps output at 10.2. So 0.2 is the error. So this one is can be still used. Okay, but I believe this what we call this 3 milliamps at 0 pressure will be not good for the PLC. So it will give some abnormal error. But emergency, we can still use this one. So maybe this is as backup. Okay, so you see 0 pressure 4 milliamps. So maybe this is good. Right. Still have. So don't make overpressure on the sensor guys, because there's a possibility to damage the sensor. Okay. Alright. So in this case guys, it's very fast responding and good to get through the pressure. See? So maybe this sensor is good. Yes. Okay, I can solve the issue. Oh, okay. Oh, very good. So almost accurate guys. So we don't have some little error on this differential of this calibrator, but you see 10 has already 20 milliamps, moving 20 milliamps. So 11.1 guys, so we get 1.2. So this is really good. At least I have one spare good, so I can fix my problem here. Because actually this is for our ballast water treatment system. We can always alarm. Alarm was some PT is offline. So now I check, now it's good. So what will happen guys is at 0 pressure it will give 3 milliamps. That's the time giving alarms to the system, in our system. Okay, that's it. So let's release the pressure and go back to 4 milliamps. So okay guys, so this is really good now. I hope you learned this video, and please like and follow and share my video guys. So okay guys, thank you. Germans 2.0 is now signing off.